Hello and good morning, Math 3 Honors. So this video should be for Thursday, that's January the 28th. And for today, I'd like to introduce you to this concept of common angles and common trig that goes with those angles. So this is definitely something that it's not so much that it has a concept behind it, it's more of something that is commonly used, and it's something that it's better if you memorize it. This is definitely one of those things where flashcards, I think, would help. I'm not usually a big proponent for saying like, hey, you can just memorize this, but I would say that this particular topic is one where you just need enough exposure that you just need to know these kind of by heart. And so, I recommend making some flashcards. I recommend just kind of repeating them over and over until you really just understand them. So without further ado, let's go ahead and get started. I'm going to first of all start with sharing a whiteboard to kind of explain what's happening and where it's coming from. So there's two types of triangles that are special right triangles, I guess. They're common triangles. And so I am just going to very roughly draw them. So this right triangle is one where you have a right angle here, and then this would be 30 degrees, and this would be 60 degrees. Okay, this is very common. It's very common in a lot of applications. A lot of times when you're trying to find areas of regular shapes, or you're trying to deal with real world applications where you're taking something that is a regular hexagon or something like that, this triangle tends to come up a lot. It just appears a lot in everyday use, so it's pretty good to know. Now, we call it the 30, 60, 90 triangle. Notice that because this angle is more open, it's got 60 degrees, this side would be bigger than this side. So this side is not as large as this side. And the values that go with these angles, or with these sides, are in a certain proportion. So what that means is that you can scale them up or scale them down, but they always have the same ratio to each other. So commonly what it's expressed is that the hypotenuse would be 2. The side across from 30 degrees would be 1, and then the side across from the 60 degrees would be square root of 3. This is one way to commonly represent it. I think, and actually a better way, and one that fits in more with what we've been doing, is to have the hypotenuse equal 1. Okay, now since the ratios are maintained, when this was 2, this was 1. So now that this is 1, this is going to be a half. Everything got divided by 2, you can say. So instead of being square root of 3, this is going to be square root of 3 over 2. Okay, so these values are very common and very useful to have. And I'll point out some interesting things here. So for example, we would say that the sine of 60 degrees, let's see, can I pull that up? So the sine of 60 degrees would be the square root of 3 over 2. I do it like this. Right. We would say that the cosine of 60 degrees, you can imagine kind of tilting your head and turning the triangle the other way, right? The cosine of 60 degrees would be 1/2. And likewise, the sine of 30 degrees would equal 1/2. And the cosine of 30 degrees would equal the square root of 3 over 2. Okay, these are very common values, and again, flashcards would really help you. So it should be, these should kind of be automatic or close to it. So this is one triangle, some values here. Then the other triangle, there's one more, which is the isosceles right triangle. That came out pretty good. Let's see. So the isosceles right triangle is one that has, we call it the 45-45-90 because it has a 90 degree and it has a 45 degree angle and it has a 45 degree angle. And just like before, the common sides here, the way the sides are commonly expressed is 1, 1, and the square root of 2. However, to kind of deal with this and make it so that the radius is 1, or excuse me, the hypotenuse is 1, it's actually better to call this 1, and then this would be 1 over root 2, which actually simplifies into root 2 over 2. And this would be root 2 over 2. Okay, so this, again, this is very common as well. So we could say the sine of 45 degrees equals root 2 over 2. And the cosine of 45 degrees also equals root 2 over 2. And again, these are very common. Oops, just over the numerator. So if I were you, I would probably make a flashcard for each one of these and just kind of practice it over and over. And another thing that I would do is I would also attach or make separate flashcards for the radian versions of these. So you have sine of 60. So the radians that matches 60, if you recall, when we're talking about radians, 2 pi radians is the same as 360 degrees. 360 degrees. So pi radians is 180 degrees. Oops, 180 degrees. Need a better mouse. And that means if you divide by 3, right, pi over 3 radians equals 60 degrees. Cut this in half, pi over 6 radians equals 30 degrees. Right, so I would make separate ones here and say sine of pi over 3 radians equals root 3 over 2, sine or cosine of pi over 3 radians equals 1/2, sine of pi over 6 radians equals 1/2, cosine of pi over 6 radians equals 30 degrees. And then for the 45, that would be 180 divided by 4, so that's pi over 4, right, equals 45 degrees. Okay, so this is kind of the basic fundamental understanding of this. Now, like I mentioned, there's really not a lot of explanation into why these are the numbers that they are, but it's still very useful to have them memorized. So now I want to show you the kind of problems where these pop up and maybe do a little bit of practice with you guys. So let me go ahead and share my screen over here. Yep. So right here, here. So we're going to go ahead and open this with Cami. Now this will be posted for you to practice as well on Google Classroom. Okay, so it's just a bunch of different exercises. I also went ahead and posted up a table of, you'll see it on the Google Classroom, but it'll be like all the common ones. So it'll be all the stuff that I just showed you. But it's in a table, like it's in a chart. So it kind of makes it easier to see. So tangent of theta, where theta is 60 degrees. Let's think about this, okay? So tangent of theta, or in other words, tangent of 60 degrees. Remember, tangent equals sine over cosine. So sine of 60 over cosine of 60. Now, if we remember, sine of 60, the side across from the 60 was the bigger one, so that was the root 3 over 2. So the top would be the square root of 3 divided by 2, right? That would be the sine of 60, and then we would divide that by the cosine of 60, which was a half. So we have the square root of 3 over 1, or just the square root of 3. So the tangent of 60 degrees is the square root of 3. And you can see that in order to figure that out, it helps if you have these kind of memorized. Okay, let's do another one. Okay, we have the sine of, let's get rid of this, sine of 225 degrees. So 225 degrees is 180 plus 45. So this is 45 degrees right here, which means that the sine of this would be the same as like the sine of 45 degrees, right? Except it's negative because it's pointing down. So again, what's the sine of 45 degrees? That's the square root of 2 over 2. And this one would be negative. So right, this would be the same sine as the sine of 45, except negative. And so that's what that would be. Let me go ahead and put a box around my answers like this. All right, let's look. So the sine of 90 degrees. So you're turning 90 degrees. This is actually just 1. This one doesn't really go with what I'm trying to teach you. So we'll just, sine of 90 degrees is just 1. Cosine of 150 degrees. Okay, so 150 degrees, you can see that the cosine would be like from here to here. This would be the cosine. And that would be the same as if the cosine was over here, right? It's just mirrored on the left and the right, it's mirrored. So, except it's negative, and this angle here would be 30 degrees because you've got 180 and 150. So this is actually the mirror to having it be like sticking out over here. This would be 30 degrees over here. So it's just the negative mirror of that. So cosine of 30 degrees, we can use cosine of 30 degrees to figure it out. And if you recall from the triangle, right, so if this is 30, cosine would be down here, which is root 3 over 2. This is a half. So the cosine is root 3 over 2. And this is the negative because it's on the left side. So it's negative root 3 over 2. Okay, let's keep going. Cosine of 90 degrees is going to be 0 because when your side is here, right, you're not extending to the left nor to the right. You're just nothing. So this is a 0. Again, this one doesn't really tie into the common angles, but still worth knowing. Cosine of 90 is 0. Okay. Oh, here, tangent of 240 degrees. So this would be 180, and then this is 60, right? So this is 60 here. And remember that tangent is sine over cosine. So if we can find the sine of this and the cosine of this and we just divide it, then we're fine. So this sine this way would be like the sine of 60, but it's negative, right? Because this is just the mirrored version of that, and that's just the mirrored version of that. So what's the sine of 60? That's going to be root 3 over 2. Okay, again, that memorization piece. And then the cosine of 60 is 1/2, right? Because these are both down here, right, you've kind of got a negative cosine and a negative sine, so both of these are negative, which means they end up canceling out. And this 2 cancels here. You get square root of 3 over 1, which is just square root of 3. So the tangent of 240 is just the square root of 3. Probably have time for maybe one more. So the cosine of 135, so that's kind of like the cosine of 45. So if 45 is this way, right, this would be the cosine of 45 would be here. But since it's mirrored over to the other side, right, because this is 45 right here. Remember that isosceles right triangle? So that's going to be square root of 2 over 2. Because it's the cosine of 45 degrees. Do you have time for one more? Yeah, maybe. So tangent of 150. So tangent of 150, again, sine over cosine. So this is going to be 30 degrees. So we need to find the sine of 30 degrees. And it is positive. So sine of 30. That's going to be a half. Again, that memorization really helps. Right? Sine of 30 is a half. And then the cosine of 30 is square root of 3 over 2. However, because this cosine is negative, right? We're just using the cosine of 30 because that's what this is, but it's still negative. We're still technically finding the cosine of 150. It's just that we can relate it to the cosine of 30. So this one is still negative because we're still finding this. Okay, and this is going to be 1 over the negative square root of 3. Normally we don't like square roots on the bottom, so we can go ahead and multiply the square root of 3 like this. And this will just become the square root of 9, which is just 3. So we have negative square root of 3 over 3. Negative square root of 3 over 3. And that's the tangent of 150 degrees. Okay, anyway, so there's a whole bunch more problems. Now, you'll see some of these here that say cosecant or cosecant, right? CSC, or cotangent. There's another one that says secant somewhere, I think, right? Yeah, like this one. Okay, these are trig functions that we haven't gone over in class, so you don't have to worry about these, right? Just worry about sine, cosine, and tangent. And these ones with the subtractions, or I should say with the negative angles, you can give these a try, right? Negative angles just means you're rotating or I guess you're rotating clockwise instead of counterclockwise. But I would say mainly try to focus on the ones that we're familiar with, and maybe some of the radian ones as well. Okay, so I will see you Monday, but you'll probably see another video of me again tomorrow. For the rest of the period, if there's still time, you should definitely be working on some of these, and also be working on those flashcards. It's real important. So I will see you on Monday.